Hello and welcome to another exam paper walkthrough. Today I'm going to be continuing with the GCSE Maths Edexcel predicted topic papers. So this is a paper I've produced for the paper 2, paper 3, so the calculator paper, and this is what I'm calling a good chance paper. So attached to the description to this video, you'll find a link to a Google Drive where you can download a copy of the paper. If you've not already done so, I'd recommend you do that before watching the video, and either do the paper before the video or do it alongside the video, whichever works better for you. This is in preparation for the June 25 examination series. The topic list has been produced by First Class Maths. If you've not checked out their website, please do that as well. If you find this video useful, please do subscribe if you like, and you'll get notifications as soon as my other videos become available, which includes a very likely paper, or what I'm calling a very likely paper. So, First Class Maths have done an excellent job in analyzing the topics that have appeared so far, and they've produced what they're calling a 5-star, 4-star, 3-star. They've got 2-star and a 1-star, but I've kind of ignored those for now. And I've produced 2 papers. I've produced a very likely paper, which I'm calling very likely, and that's based on their 4-star and 5-star topics. Obviously, that's no guarantee that those topics will appear. It's just based on the frequency analysis that they've done. It is what they're viewing as 4-star, 5-star. I'm calling them very likely topics, but that's my choice. And I've produced a good chance paper, which is all based around their 3-star topics, which is this paper. So shortly, the very likely paper video will be available. The paper is already available, so please do have a go at that in the meantime. Right, let's get on with the paper. Okay, so question 1. Nick is going to buy 15 rolls of wallpaper. Here is some information about the costs of wallpaper from 2 shops, and then we've got conditions. Nick wants to buy 15 rolls of wallpaper as cheaply as possible. Should he buy from which of the 2? You must show how you got your answer. So I'm going to write down, I'm going to break it into 2 kind of sides. So for chic decor, if I've got this deal is for 3 rolls, so I need to do 15 divided by 3. That will tell me how many of the deals I need, times by 36. And then we'll go to our calculator in a moment. For style papers, so I'll go SP, 5 rolls, so the deal is for 5 rolls, so I'm going to do 15 divided by 5, and I'm timesing that by 70 to find out the price. And we've got this deal 12% off the normal price. So 12% off the normal price means that we're only paying for 88%, which would be a multiplier of 0.88. So I want to times that by 0.88. Right, and I'll bring up my calculator. So I'm using my emulator for this. If you've got a different calculator, it shouldn't really affect much of what we do. I'll talk about any special functions that we use though. So the first price is going to be £180, and then the second price is going to be 15 divided by 5 times by 170. Times by 70 times by 0.88. So, and that's going to give me £184, £184 and 80 pence. So this one is cheaper. So should Nick buy wallpaper from? So we go, Nick should buy from chic decor. Chic decor. And we'll just put it in as 180 is less than £184.80. Okay, question 2. The scatter graph shows information about a group of about the marks a group of students got in a science test and a maths test. So maths tests on the y-axis, science test on the x-axis. Neville got 34 marks in the science test. Use the scatter graph to find an estimate for Neville's mark in the maths test. Okay, so I'm going to draw a line of best fit. For any question like this, line of best fit. Speed. So line of best doesn't need to go it just needs to be a suitable representation for the data. So I'm going to go. So I'm going to say this is going to be roughly my line of best fit. So yeah, I'm happy with that. So use scatter graph to estimate Neville's maths mark. So 34 was his science mark. So 34, I'm going to go up to my graph. And then where that hits the line, I'm going to go off and read my y-axis. So we're looking at roughly 41 marks there. And for typical questions, you've got a bit of a range of values that are acceptable there. I actually think that will do. Really, I think my line of fit's arguably slightly off. That might have been a slightly better one, which brings my mark down lower. But anything in those region is pretty acceptable. Question 3. T is equal to 4m squared minus 11. Work out the value of t when m is equal to minus 3. So we've got some substitution. Whenever I substitute a negative number, I always like to put the negative number in brackets, particularly important for a question like this. And then technically speaking, we can actually just type this into our calculator. There's no need to overly complicate it. And I've missed my 3 there. 3 squared minus 11. Before I press equals though, we'll just see what we think it should be. So minus 3 squared is going to be 9. Minus 11, so 36 minus 11, so I think 25. Yeah. Okay, part B, make P the subject of the formula. So we want to isolate P. To do that, our first step is to get rid of a plus 4. So we'll minus 4 from both sides. So D minus 4 is equal to 3P. And then we want to get rid of this times by 3, so we divide by 3. So D minus 4 divided by 3 is going to be equal to P. And there's our rearranged, or making P the subject. D minus 4 all over 3. Question 4. Fred, George and Ron are playing a game with counters. Fred has some counters. George has twice as many counters as Fred. Ron has 6 counters less than George. In total, they have 54 counters. The number of counters Fred has to the number of counters Ron has is 1 to P. Work out the value of P. Okay, so we'll go F to G to R. That's starting point. And then let's say Fred is going to be X. George has twice as many, so that would be 2X. Ron has 6 counters less than George, so that would be 2x minus 6. In total, they have 54, so those need to add up to 54. Right, so I'm going to solve this for x to start with, although I actually want Fred to Ron, so I actually want these two ratios to each other. Right, so if I add these up, that would give me 5x minus 6 is equal to 54. Add 6 to both sides, 5x is equal to 60. Divide both sides by 5, x is equal to 12. So that means that I'll bring this ratio back down. So Fred to Ron is going to be 12 to 24, take away 6. So that's 18. 24, yeah, 18. Double check just because on a calculator paper it's always best to check. 12 times by 2 minus 6 is 18. And we wanted it in the form of 1 to P. So if I divide both sides by 12, that would give me 1 to 18 divided by 12 is going to be 1.5. 1.5. So 1.5 Right, question 5. Guinea runs for 15 minutes at an average speed of 6 miles an hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Luna 45 minutes to run the same total distance that Guinea runs. Work out Luna's average speed. Right, so if we look at Guinea first of all, so if she runs in a quarter of an hour, she runs 6 miles an hour. So we want a quarter of 6. So quarter times by 6 is going to be 1.5, I believe. So 1 over 4 times by 6 is 1.5. So she's run 1.5 hours in the first miles in the first 15 minutes. And then she runs for 40 minutes. Well, 40 minutes is 20 minutes is a third of an hour. So that's 2/3 of an hour. So we'll do 2/3 times by 9, which is going to be 6 miles. So in total, she's run 7.5 miles. Right, if Luna takes 45 minutes to run the same distance that Guinea runs, work out Luna's average speed. So we shall say that speed is equal to distance divided by time. And then we need to say that the distance is 7.5, but 45 minutes is 3/4 of an hour. So we're going to be dividing by 3/4, which is going to be the same as times by 4 divided by 3, but we'll leave it like that for a non-calc, for a calc, sorry. And we can actually, even if we wanted to, we can say that a quarter of an hour is 0.75 of an hour. So that's going to be a speed of 10 miles per hour. Okay, question 6. Here we've got a Venn diagram. So the universal set is the numbers 1 to 10. Set A is even numbers. Set B is factors of 10. Complete the Venn diagram for this information. Okay, so let's start with, I'm going to run through the list. So 1 is a factor of 10, but it is not even. So 1 would go there. 2 is a factor of 10 and even. 3 is neither. 4 is an even number. 5 is a factor of 10 but not even. 6 is even but not a factor of 10. 7 is neither. 8 is even but not a factor of 10. 9 is neither. And then 10 is both. There we go. So I will always tend to try and list this in kind of going down in size order just to make things easier for my marker. Right. A number is chosen at random from the universal set. Find the probability that the number is in the set A and B. So that's the intersection. So we've got 2 digits in the intersection. And we've got a total of 10 numbers. So 2 over 10, which I would say is 1 over 5. Right, question 7. Use algebra to solve the simultaneous equation. 2x plus 6y is equal to 15. 3x minus 4y is equal to minus 12. So for this, I either need to make my x coefficients or my y coefficients the same value. I'm looking at 6s or 12s. Completely up to me. I think I'm going to go 12s. Yeah. So if I times the first equation by 2, that would give me 4x plus 12y is equal to 10. And if I times the second equation by 3, that would give me 9x minus 12y is equal to minus 36. And then now I've got 12 in both. One's a positive, one's a negative, so I'm going to add the 2 equations together. So if I call that 3 and 4, I'm going to say equation 3 plus equation 4 is going to be equal to 13x is equal to minus 26. So x would be equal to minus 2. Right, I'm going to take that value for x and I'm going to place it into one of my two original equations. I'm going to go equation 1. So 2 lots of x is going to become minus 4 plus 6y is equal to 5. If I add 4 on both sides, that would give me 6y is equal to 9. And then divide both sides by 6, y would be equal to 1.5. So I've got x is minus 2 and y is 1.5. And I can do a quick check to, and I'll do it up here. So I'm going to check with equation 2. So 3 lots of x is going to become minus 6 plus 4 lots of 1.5. That's going to become 4. That's going to become 6. So it's minus 6. And that is equal to minus 12, which tells me that I'm going to be right with my answers. Okay, question 8. The table shows information about the heights of 80 plants. Find the class interval that contains the median. So for the median, if I've got 80 plants, what I'm looking for is the position of, to find the position of the median, you do 80 plus 1, the total the plus 1 divided by 2 is going to be 40.5. So technically I'm looking for the 40th and the 41st value. And I'm going to find which group will contain those. So if I keep a running total of the frequency, I'll call it the cumulative frequency, so 13 plus 7 would be 20, 20 plus 14 would be 34, and then 34 plus 12 would give me 46, which means that the 40th and the 41st are both in this group here. So my interval containing the mean would be h is greater than 40 but less than or equal to 50. Okay, on the grid draw the frequency polygon for the information in this table. So for my frequency polygon, I'm going to plot them at the midpoint. So the first one will be at 15, 17. Let's make that nice and big so I can see the scale. So 6, 7, so 15, 7. My next one is going to be at 25, 13. So 25, 13 is going to be 1, 2, 3. That's going to be there. My next one's going to be 35, 14. So 35, 14 is going to be there. My next one will be 45 and 12. So 45 and 12. So 45, 10, 12. And then I'm looking 55, 16, 55 and 16 will be here. And then finally 65 and 18. So 65 and 18 will be there. Now I'm not going to join it to the origin. I should really use a ruler to join these points, but we should be joining them with straight lines. So that's going to be roughly my frequency polygon. Obviously, you should use a ruler for that, though. Right, question 9. The cumulative frequency table gives information about the age of 80 workers at a company. On the grid opposite, draw a cumulative frequency graph for this information. So I'm going to plot each of these at the maximum value for a cumulative frequency. So my first point is going to be at 3020. My second point is going to be at 4048. Next point will be at 5064. We're then going for 6075. And then our final one is 7080. And we need to join these up with as smooth a curve as we can. I'm not going to join it to the origin. So it's always easier to draw a curve with your wrist on the inside of the curve. But that's going to be roughly my cumulative frequency. And there was a part B, wasn't there? So part B Use your graph to find an estimate for the median age. So if this is out of 80, we're going to take our median for as being 40. So we go across to our graph. Where we hit our graph, we go down and read off our value. So we're looking at about 37 there. Question 10. Here are four graphs, graph A, B, C, D. So we've got what looks like a sine curve, possibly a cubic, a reciprocal. We've got a root, and we've got a exponential. Right, so match the description to the graph. So inversely proportional to x. So that means as one goes down, the other goes up. So that's going to be graph D. Sorry, B. Trigonometric function would be graph A. The exponential function would be graph D. And then directly proportional to root x would be C. Right, question 11, solve. So occasionally I'll try and divide by 3 first of all. However, as both these terms aren't divisible by 3, I'm going to expand the bracket. So that's going to be 5x minus 6 is equal to 3x minus 3. I've got more x coefficients on the left, so I'm going to minus 3x from both sides. That will give me 2x minus 6 is equal to minus 3. Add 6 to both sides, that will give me 2x is equal to 3. So x is going to be equal to 3 over 2, or 1.5. Question 12. Liquid A has a density of 1.8 grams per centimeter cubed. Liquid B has a density of 1.2 grams per centimeter cubed. 80 centimeters cubed of liquid A is mixed with 40 centimeters cubed of liquid B to make 120 centimeters cubed of liquid C. Work out the density of liquid C. So for any compound measures where we've got two parts, well, three parts really, I like to put them in a little table. So I'm going to go density, mass, volume. And our density can't just be found by adding the other two values together. We've got to do a bit of working because density won't work like that because it's the compound measure. So the density of A is 1.8, the density of B is 1.2. The volume of A is 80, the volume of B is 40, and they have a combined volume of 120. So we need to work out both these masses of A and B, add them together, and then work it through from there. So density is equal to mass divided by volume. So that means that mass is going to be equal to density times by volume. So I'm going to do that for mass of A, then is going to be equal to 1.8 times 80. And the mass of B is going to be equal to 1.2 times by 40. Right. So 1.8 times by 80 gives us 144. And then for B, we're doing 1.2 times by 40. And that gives us 48, making their combined mass 192. So as we said, that density of C is going to be equal to mass divided by volume, so 192 divided by 120. So divide that by 120 gives us 8 over 5, which is going to be 1.6. Over and got our unit. Right, 13. In 2010, Dolores bought a house. In 2007, Dolores sold the house to Rufus. She made a 20% profit. So that would be a multiplier of 1.2 if I call this value x. In 2012, Rufus sold the house for 162,000. He made a 10% loss, so that would be a multiplier of 0.9. How much did Dolores pay for the house? So we're going to say that x multiplied by 1.2 multiplied by 0.9 is going to be equal to 162,000. So the original value would be 162,000 divided by 1.2 times by 0.9. So 162,000, just checking sure I've got the right numbers. We'll do it as a fraction. Divided by 1.2 times by 0.9 will give us a value of 15,000. That looks too small. There we go. I missed a decimal point there. There we go. That's more like it. So 150,000. Right, question 14. Factorize fully 4p squared minus 36. So this is the difference of two squares. What I can do is take out a factor of 4 just to make it a bit simpler. P squared minus 9. So that means that 4 times by p plus 3 times by p minus 3. So 4 times p plus 3 p minus 3. Part B, show that can be written, we've got a triple bracket, can be written in the form am to the power 3 plus bm to the power 2 plus cm plus d, where a, b, and c and d are integers. So whenever I'm expanding a triple bracket, I like to expand I like to save the easier bracket for my last step. So I'm going to expand this bracket first of all. So 2m minus 5 times by 3m plus 1 is going to give me 2m times 3m will give me 6m squared. 2m times by 1 will give me plus 2m. Minus 5 times by 3m will give me minus 15m. And then minus 5 times by 1 will give me minus 5. Simplify my middle terms. That's going to give me 6m squared minus 13m minus 5. Right, now I'm going to bring in that final bracket. So I'll kind of make sure what I've written is correct. So I should have times included this. So m plus 4. Absolutely fine to use this using the grid. I tend to set it up as kind of a column just to keep my things. So if I times everything by m, I'd get 6m cubed minus 13m squared minus 5m. Now if I times each of these terms by 4 and line them up, that would give me 24m squared. 26 minus 52m minus 20. And now if I add those, they're kind of set up nicely to add. Right, so I'm going to get 6m cubed. If I add those together, I'd get plus 11m squared minus 57m minus 20. There we go. Okay, question 15. Okay, so here we've got two non-rectangle triangles. Work out the length of AD. So if I start by calling that X, just to help me plan this out before I do it. So I've only got 2 bits of information in this triangle. I would need 3 bits to work out X. So I would need this length here first. And I can work out that length there using the sine rule. And then I can work out using the cosine rule. So I'm going to start by saying that so y over sine 34 is going to be equal to 12.5 over sine of 109. Right, I'm going to go a bit further before I bring up my calculator. I'm going to say that so x squared is going to be equal to y squared plus 11.4 squared minus 2 lots of y times by 11.4 times cos of 86 So back up here, I'm going to say then, so that y is going to be equal to, and I'm going to do this just as one step. Actually, we'll go 12.5 times by sine of 34 divided by sine of 109. And I'm not going to go any further than that because I know that I'm going to get a decimal that I'm going to use in this second answer. So we will go. So, right. So I'm going to type it in as a fraction. 12.5 times by sine of 34. Just trying to double check my numbers as I type. Divided by sine of 109. So that's going to be my value of y, but I don't really want to round it, so I'm going to jump straight into my second equation, and I'm just going to use my answer key. So I'm going to say my answer squared plus 11.4 squared minus 2 lots of my last answer times by 11.4 times by cos of 86. And that gives me my value for x squared. So I'll write that down, 172.853 ... to imply that I've not rounded it. So x is going to be the square root of that then. So square root of my last answer gives me 13.1. Again, I'll write that down without any rounding. So 47 ... Then I want three significant figures, so I'm going 13.1. Right, question 16. In an experiment, 60 students each complete a puzzle. The cumulative frequency graph shows information about the times taken for 60 students to complete the puzzle. Okay, for the 60 students, the least time taken was 24 seconds. The greatest time was 96 seconds. On the grid below, draw a box plot for the distribution of the times taken by the students. So my lowest is 24. So we'll add that as a line here. My greatest was 96. So I've just messed up on my scale slightly there. So these are actually going up in twos. So 24 would actually be there. 96 would be there. And then we need to work out our median first of all. So if we've got 60, we'll, for a cumulative frequency, we take the median as 30, and then we read that value off, which is looking like 54. So 54, which would be in there. That's our median. Our lower quartile would be at 15, which is looking like 42. And then our upper quartile would be at 45, which is looking like 64. And then we just complete it into a box plot. There we go. Question 17. Use the iteration formula x of n plus 1 is equal to the cube root of 10 minus 2xn. To find the values of x1, x2, x3, start with x0 is equal to 2. Right, so on my calculator, I'm going to start by pressing 2 equals, and then that will make my the answer stored within my calculator as 2. I'm then going to type in cube root of 10 minus 2 times by my answer. And then every time I press equals, it will give me my next value. So 2 equals, and then I'm going to type in the cube root of 10 minus 2 lots of the answer. So my first value is going to be 1.8171. And we'll go, yeah, 4 decimal places. Doesn't state how accurate. The next value then would be 1.8533. And then my final value would be 1.8462. The values of x1, x2, and x3 found in part A are estimates of the solution of the equation in the form x cubed plus ax plus b is equal to 0, where a and b are integers. Find the values of a and b. Right, so what I'm going to do is I'm going to start with the equation, and I'm going to not write these parts. I'm just going to write them as x to start with. So x is equal to the cube root of 10 minus 2x. Right, so I'm going to cube both sides now, and that will give me x cubed is equal to 10 minus 2x. And then I'm going to take everything over to the left-hand side. So that would give me x cubed plus 2x minus 10 is equal to 0. Right, and that means then that a would be equal to 2 and b would be equal to minus 10. Okay, question 18. The diagram shows two similar solid triangle prisms, A and B. The volume of prism A is, the volume of prism B is. The cross-section of each prism is a right-angled triangle. For prism B, the length of the base of the triangle is 8.1. The area of the triangle is 43.74 centimeters squared. The height of triangle A is h. Find the value of h. Okay, so my first step here is to look at the volumes. So what I'm going to say is that the volume scale factor, I'm going to say volume SF, is going to be equal to the volume of B, which is 1587.762, divided by the volume of prism B, which is 58.806. And I'm hoping that's going to give me a nicer number. We're looking about 25-ish. 25 would be nice. No, it wouldn't actually. So let's have a look. 1587.762 divided by 58.806. Double check my numbers there. 27. That is perfect. So if the volume scale factor is 27, that means that the length scale factor is going to be equal to the cube root of 27, which is going to be 3. There's a scale factor of 3 between the lengths of these shapes. Right, so the next thing I'm going to do is, if this is h, what I'm going to do is I'll take this length next. I'll call it x for now. So the area of the triangle is equal to a half of x times by 8.1. So we know that the area is 43.74. So that's going to be a half of 4.1, which would, a half of 8.1, which would be 4.05, 4.05x. What I've done there is half 8.1. So x is going to be equal to 43.74 divided by 4.05. So let's do that. 43.74 divided by 4.05. We're looking at a value sort of 10-ish, 10.8. So that length there is 10.8. Right, so to get from this length, we've got a length scale factor of 3. So what I'm going to have to do is say that h is going to be equal to x divided by 3. Is the smaller one, so we're dividing by the scale factor, so that's going to be equal to that value divided by 3, 3.6. So h is going to be 3.6 centimeters. We've got a unit there, so we include our unit. Right, question 19. PQRS are 4 points on a circle. Okay, PXR is and S X, Q are straight lines. Prove that PQX, so P to Q to X, so this angle here. And, sorry, prove that the triangles are similar. Right, okay. So we want to prove that this triangle is similar to this triangle. Okay, so planning that then. So we're going to say that these angles are equal because they're from the angles to the circumference from the same chord are equal. We're also going to say that these are equal for the same reason, and then we're going to say that this is vertically opposite. And that will prove that they're similar. There's an argument that they could be congruent, and we'd need to prove that they weren't congruent, but we don't need to do that. Right, so let's explain that then. So I'm going to say that QPX is equal to XR. And the same logic is going to say that PQR, I'll explain my reason in a moment, is equal to XRS. And those are the same reason, so I'll kind of put that reason in shortly. And then I'm going to say that PXQ is equal to SXR. Then as all three angles are equal, if I spelled 3 wrong, right, all three angles are equal, so must be similar. Right, now let's put our reasons in. So our circle theorem, technically angles at the circumference descended from the same chord are equal. So I'm going to put the same reasoning for these two. Angles at circumference from same chord are equal. And then this reason is vertically opposite angles are equal. Equal. Okay, I'm just going to add a bit of color just to clear that up. So this is the same reason, and then this is my second reason, and then that's my summary. Okay, question 20. The diagram shows a cube and a cuboid. The total surface area of the cube is equal to the total surface area of the cuboid. Hermione says the volume of the cube is equal to the volume of the cuboid. Is Hermione correct? You must show how you got your answer. Right, so I'm actually going to have to work out, I'll call this length x for now. Right, so let's start with the surface area of the cube is going to be equal to x squared times by 6, because we've got 6 faces. The surface area of the cuboid is going to be equal to 2 lots of 6 times 8 plus 8 times 18 plus 6 times 18. So that will give you the front and the back, the bottom and the top, and then the left and the right. And 2 lots because we've got 1 of each. So we'll go to our calculator for that. So we're looking at 2 times by 6 times 8 plus 8 times 18 plus 6 times 18. That gives me 600, which is quite nice to work with. That's very nice. Right, so if these surface areas are equal, we can say then that 6 lots of x squared is going to be equal to 600, which means x squared is going to be equal to 100. So x is equal to 10. We could argue a negative, but we can't have a negative length. Right, so based on that, the volume of the cube, so the volume of the cube is going to be equal to 10 cubed, which is going to give us 10,000. And then the volume of the cuboid, like that. So the volume of the cuboid, I'm just going to change this and call them shape A and shape B. So the volume of shape A is 1,000. The volume of shape B is going to be equal to 6 times 8 times 18. So 6 times 8 times 18 is going to be equal to 864. So those are my, I'll put the units in as well, centimeters cubed, centimeters cubed. So no, she's not correct. No, Marnie is not correct. And we'll say as 1,000 centimeters cubed is greater than 864 centimeters cubed. Right, question 21. Here is a triangle ABC. Find the length of BC. So we want this length here. We'll call it X for now. Give your answer to 3 significant figures. So this is, we're looking at the cosine rule. So we've got 3 sides and an angle of a non-right angled triangle. So we're going to say that x squared is going to be equal to 8 squared plus 11 squared minus 2 lots of 8 times 11 times in times by cos 72. Right, so 8 squared plus 11 squared minus 2 times 8 times 11 times by cos of the angle 72 is going to be equal to 130.613 dot dot dot. So x is going to be equal to the square root of that. So square root, my answer gives me, and again I'll write it more accurately than needed to start with, dot dot dot. No rounding happened. 3 significant figures, 1, 2, 3. So that's my 3rd significant figure. So I'm looking at 11.4. Right, part B, find the area of the triangle ABC. Give your answer correct to 3 significant figures. So I don't want to use this answer, but it works quite nicely. The area of a non-right angle triangle is going to be equal to a half of AB sine C. AB sine C. So that's going to be equal to a half of 8 times 11 times by sine of the angle, which was 72. So that's going to give me 0.5 times by 8 times by 11 times sine of the angle, 72. That gives me an area of 41 point, so we write it more accurate. Dot, dot, dot. So 3 significant figures, that's going to be 41.8. Right, question 22. The graph of the curve of equation y is equal to f of x is shown in the grid below. On the grid above, sketch the graph of the curve of the equation y is equal to f of minus x. So if the negative is inside the bracket, it's a reflection in the y-axis. So that point will be an invariant point, won't move. This point will move to here. This point will move to here. And then the final point will be there. Let me just try and, as close as we can, match that curve. I'm notoriously bad on the screen doing that, but that will do. Get that up slightly. Okay, the curve C with equation 5 plus 2x minus x squared is transformed by a translation to give the curve S such that the point 1, 6 on C is mapped to the point 4, 6 on S. Find the equation for S. Ignore the equation for now. We'll call it f of x. And then if we're moving, we've changed our x coordinate by 3. So we've mapped it to f of x minus 3. So if in this equation I replace x with x minus 3, that will give me my equation. So y is going to be equal to 5 plus 2 lots of x minus 3 minus x minus 3 all squared. And for a 2 mark, I think that will be absolutely fine for my answer. As a higher student, I am able to simplify this, so I'm going to do that. But I suspect that that would be fine for my answer. So that would be 5 plus 2x minus 6 minus, if I square this bracket, I would get x squared, so it's going to be minus x squared. I'd get minus 6x, which would become plus 6x. I'd get plus 9, which would be minus 9 because of this negative here acting on all parts. So that would be minus x squared plus 8x minus 5 minus 1 minus 10. So that's a slightly better answer. So I've just expanded the brackets. But like I say, I think you would pick up for 2 marks. That would be fine for your answer. Right, question 23. Y is inversely proportional to the square of x. So we'll start by saying y is equal to k over x squared. When y is equal to 8, x is equal to 2.5. Find the negative value of x when y is equal to 8 over 5. So we will, we'll use the equation of proportionality. So we'll use this equation. The ratio method is becoming more and more popular. However, I'm not going to use it for this. So 8 is going to be equal to k over 2.5 squared. So k is going to be equal to 8 times by 2.5 squared. Right. So 8 is equal times by, don't really need the bracket, 2.5 squared. So k is going to be equal to 50. Right, so y is going to be equal to 50 over x squared. And we want to find x when y is 8 over 9. So 8. So we can kind of rearrange this to say that x squared then is going to be equal to 50 divided by y. X squared is going to be equal to 50 divided by y. And I'm going to use my calculator and take the negative value, the square root of 50 over 8 over 9. I can type it in like that. So the square root of fraction on my top line, I'm going to go 50. And on my bottom line, shouldn't really do this, but we've got 8 over 9. So that's going to give me x is equal to 15 over 2, which would technically that's plus or minus for now. So we'll go x is equal to plus or minus 15 over 2. So the value that I'm after is the negative one. So x is going to be equal to minus 7.5. So minus 7.5. Okay, question 24. The diagram shows a triangular prism with a horizontal rectangular base ABCD. Okay, M is the midpoint. The vertex T of the prism is vertically above. Okay, so that's implying that we've got a right angle triangle there. We're given some of the dimensions. Point P is on AB such that, so we'll put that just roughly there for now. Calculate the size of the angle between TP. So that's there to, let's clear up that with a straight line, just to make it a bit more friendly. So we're after the angle between that and the base. So we're actually after that angle there. Right, so to do that, we're going to have to treat it as, I'm going to treat it as 2 separate triangles. The first triangle I'm going to look at then is going to be MAP. So Always useful to draw a diagram to visualize it a little bit better. So if we call that M, T, and P. And I'm also then going to have to look at, I'll change pen color and try and keep my working constant. Then we've got as, let me just change the notation there. So I'm actually, that's going to be the bottom triangle. So let's call that AM, or keep our color consistent, or try to anyway. So we've got M there, no, we've got A there, and T there. So that's that triangle there. And then we're going to the other triangle, right angle triangle. Not change color like I said I would, but that's okay. We've got MTP there. And that's the actual angle that I'm asked to work out in the question. Let's put in the dimensions that we've got then. So we know MT is 2.3. So we know that that length there is 2.3. We know that BC, that's this length here, is 3.8, which means D to A is 3.8 as well, which means that M to A to M, which should have been this one here, A to M is half of that. So A to M is going to be equal to a half of 3.8, which will be 1.9, I think. 3.8 divided by 2 is 1.9. That makes there's 1.9. We can also work out AP. So AP is going to be equal to 5/7 of 14.7. 1/7 of that would be 2.1. So we're looking at 10.5. Again, we'll double check that though. 5/7 times by 14.7 gives us 10.5. Right, I'm going to call that length there X, M to P, which is going to be that length there. Right, and we can work out then X is going to be equal to the square root of, we've got Pythag there, 10.5 squared plus 1.9 squared, which is going to be equal to, so the square root of my last answer squared plus 1.9 squared is going to give us that value, 10.6705 ... Right, this second triangle then, so let's change color for this. So we're using trig here because we've got two sides and an angle. This in relation to the angle would be the opposite. This would be the adjacent. So we're using the tan ratio. So tan is equal to opposite over adjacent. So my angle, theta, is going to be equal to the inverse of tan of the opposite side, 2.3, over the adjacent side, which is x. Right, so that's going to be equal to shift tan to the -1 of 2.3 over the answer, my last answer. So we're looking at 12.1638 ... So to one decimal place, that's going to be 12.2. Right, question 25. OABC is the trapezium. OABC is the trapezium. O to A is A, A to B is B, and O to C is 3B. D is a point on OB such that OD to DB is 2 to 3. So 2/5 and 3/5. I like converting it to fractions. And then B to E is 1/4. 1/5. E to C is 4/5 of that length. Right, write out the vector D to E. So we want the vector of D to E, so we want this vector here. Right, so my root for that is, the ones that I'm going to work out first of all is O to B. So O to B is going to be equal to a plus b. So actually d to b is going to be equal to 3/5 of that. Right, I'm also going to look at b to c. So b to c, first of all, is going to be equal to minus b minus a plus 3 lots of b, which will simplify to being minus a plus 2b. And we're actually after 1/5 of that. So b to e is going to be equal to 1/5 of minus a plus 2b. Right, to get d to e then, d to e is going to be equal to d to b plus b to e. So that's going to be equal to 3/5 of a plus b plus 1/5 of minus a plus 2b. Right, so 3/5 of a minus 1/5 of a is going to be 2/5 of a, and I might take a fifth out as a factor shortly, but we'll do it like that for no. I might take that out, fifth out as a factor in a moment, but I'm going to do it just yet. Plus 3/5 of b plus 2/5 of b, so that would actually be plus b. So there's no point taking the fifth out. So we're looking at 2/5 of b, 2/5 of a plus b. Right. Question 26. Solve algebraically the simultaneous equation x squared minus 4y squared is equal to 9. And 3x plus 4y is equal to 7. Okay, so I'm just in two minds here at the moment. This is actually a difference of 2 squares, which I'm trying to work out whether I could make that help me out. So I might change this. So if I factorize that first of all, that's going to be x minus x plus 2y times by x minus 2y. And that's going to be equal to 9. Now, is that useful to us? Marginally, right. So I'm gonna rearrange this for x. So x is going to be equal to 7 minus 4y all over 3. So let's see how this works then. So if I substitute in for x, then I'm going to get 7 minus 4y over 3 plus 2y there. And over here, I'm going to get 7 minus 4y over 3 minus 2y is equal to 9. Right, so that's going to be equal to, if I put it all over 3 for now, 4y, that would be the same as 6y, all over 3, times by 7 minus 4y minus 6y all over 3 is equal to 9. Right, so let's tidy both those brackets up for now. So I'll do it here. So that's going to be 7 minus, 7 plus 2y over 3. Times by 7 minus 10y over 3. And that's going to be equal to 9. And then if we times through by 9, so let's try that. So 7 plus 2y times by 7 minus 10y is equal to 81. Right, now let's multiply out this bracket. So that's going to give us 7 times 7, 49, minus 70 plus 14. I'll do that. So we'll do that. So 7 minus 70 minus 70 plus 14. So minus 56y minus 20y squared is equal to 81. Let's clear up that 81. Right, I'm going to take everything over to the left, to the right to make my y's positive. So I'm going to say then that 0 is equal to 20y squared plus 56y. 81 minus 49 is going to give us 32. Right, now I'm not going to factorize just yet. I'm going to think to myself, these all appear to have 4 in common. So if I divide through by 4, 20 divided by 4 is going to give me 5y squared. 56 divided by 4 is going to give me 14. 56 divided by 4 is going to give me 14. 14y, and then 32 divided by 4 is going to give me 8. 32 divided by 4 is going to give me 8. Right, now we should be able to factorize that. So it's going to have a 5y. We'll see if it factorizes first. It's always useful to factorize. 5 is a prime number, so right, 2 numbers that multiply together to make 8. Let's think about those. I think it's going to be 2 and 4 would be the nice ones. Can I make that work over here? I can. If I put the 2 there and the 4 there, that gives me 10 plus 4. So there's my factorized version. I'm going to skip from there to there just because I want to leave space for my answer. Right, so that means that y is going to be equal to minus 4/5, or y is going to be equal to minus 2. And then if I use that to work out my value for x, so 7 minus 8, sorry, 7 plus 8, 7 plus 8 is 15, so that would be x is equal to 5. And then I'm going to use my calculator for the other one, so I want to do 7 minus 4 lots of minus 4/5 minus 4/5, and then I want to divide all of that by 3. So that's 17 over 5, which as a mixed fraction would be 3 and 2/5. So x is equal to 3 and 2/5. So I'll change pen color just to make it a bit clearer. So my solutions are y is equal to minus 4/5 and x is equal to 3 and 2/5, or y is equal to minus 2 and x is equal to 5. Okay, quite a difficult question there. You will still have worked it through exactly the same if you didn't factorize to start with. I'm not fully convinced that my method was quicker. It just kept things a bit more simple. Right, question 27. The line L has the equation 3x plus 2y is equal to 17. The point A has a coordinate of 0, 2. The straight line M is perpendicular to L and passes through A. The line L crosses the x-axis at point B. The line L and M intersect at point C. Work out the area of the triangle ABC. Right, to visualize this, I'm going to do a real rough sketch of it. The line L, so we're looking at roughly the coordinates here would be, it doesn't really matter, 17 over 3. So when y is 0, 17 over 3, we've got positive, and then we'll, okay, let's call it that. A has a coordinate of 0, 2, so 0, 2 would be roughly there. And we've got it being perpendicular to this. Right, L crosses the y-axis at B. L and M intersect each other at point C. Okay, and we want to work out this area here. Right, so the first thing I'm going to do is I am going to work out, let's start with B. So B is going to be equal to 0 on the x-axis, and then the y coordinate of B is when x is equal to 0 is going to be 17 over 2. Right, A we've already got. A is going to be equal to 0, 2. Right, so I want to work out the coordinate of C next. So C, first thing I'm going to have to do then is say that if L is equal, let's start with L and rearrange it a little bit. So L is y is equal to minus 3x over 2 plus C. We don't really care about the intercept. Oh, we actually know the intercept, 17 over 2, which works. Yeah, because we've just worked that out. Right, so the gradient of L is minus 3 over 2. So the gradient of M is the negative reciprocal of that, so that would be 2 over 3. So we can then say that y is going to be equal to 2/3 of x plus c. We know a point on that line at this point here. So when x is 0, y is 2, so we already know that y is equal to 2/3 over x plus 2. Right, so the coordinate of C is where these two lines intersect. Right, I'm now going to try and work out, I don't actually need the full coordinate of C, so just a bit of planning here. I'm going to use the base times by the vertical height. So I only actually want the x coordinate of C, which is quite nice in respect that I can say that. So 2/3 of x plus 2 is going to be equal to minus 3 over 2x plus 17 over 2. Right. I'm going to times through by 6 to get rid of my denominators here. I think, yes, I'll do that. So that's going to give me 4x plus 12 is going to be equal to minus 9x plus 17 times 3, 51. Right, so if I rearrange that, then I would get 13x is equal to 51 minus 12, 39. There we go, that's better. So x is going to be equal to 3. Right, so the difference in the y coordinates is going to be 17 over 2. Take away 2, so that's going to be 13 over 2 or 6.5. So the area of the triangle is going to be a half of 6.5 times by 3, which is going to be equal to, so 0.5 times by my last answer times by 3 is going to give me 9.75 centimeters. we'll put it here, 9.75, and the unit is going to be, we haven't got any units, so unit squared, it's squared. Right. Okay, question 28. Here are three similar triangles. A, B, C, D, and A, G, F, E are straight lines. So we've got straight lines there and there. A to B, B to C, C to D is 1 to 2 to 3. Show that the area of ABG, ABG to the area of B, C, F, G to the area of C, D, E, F is in the ratio 1 to 8 to 27. Okay, so I'm actually going to view these as triangles. So if I call this, so we're talking about the triangles. So if I call that triangle 1, and then I'll change pen color just to help me show it. I'm going to call that triangle 2, and then we'll call that triangle 3. I missed off my number 2. Right. So if I talk about the length of the triangles, I'm actually going to call it 1, 2, and 3. So the triangle 1, this length, so we'll talk about length first of all. The length for triangle 1, this length would be 1, this length would be 3, and then this length would be 6. Right. So I'll call that triangle. Triangle 1, 2, and 3, they have a length of 1, 2, 1, 3, and 6. So their area ratio would be 1 squared would be 1, would be 9, would be 6 squared would be 36. However, that's not quite the shapes that we're after. So if we think about the areas now, what we're actually going to find is the area of, so ABG, BCFG, and CDEF. Well, these F. So these are the triangles. We're after the shapes. So the triangle is going to be the triangle. The area of this one is actually going to be the area of triangle 2 minus the area of triangle 1. So that would be 9 minus 1. And then the area of the second one, the area of the third one is again, it's going to be the full area. Take away the area of triangle 2, which is going to be 36, take away 9, which would be 1 to 8 to 27, which is what we were asked to show. There we go. That's how I've gone about that. Right. Question 29. Arthur drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. Arthur's average speed from Liverpool to Manchester was 70 kilometres per hour. Arthur took 75 minutes to drive from Manchester to Sheffield. Work out Arthur's average speed for his total drive from Liverpool to Sheffield. Right, so I'm going to call this stage 1, and I'm going to call this stage 2. So a bit like when I'm working with density, I'm going to do 3 parts, and I'm after speed, distance, and time. And my basic table here then, I'm going to put in the bits of information that we've got. So Arthur drove 56 kilometres, so the distance from Liverpool to Manchester is 56. He then drove 61 from Manchester to Sheffield, that's stage 2. Arthur's average speed from Liverpool to Manchester, that's stage 1, speed of 70. And Arthur took 75 minutes from Manchester to Sheffield, which is stage 2. So 75, I'm going to say that that is an hour and 15, so 1 1/4. Yeah, 1 1/4 hours. Right, so work out Arthur's average speed from Liverpool to Sheffield. So this is our goal. So we need to work out the time that it took Arthur. So if speed is equal to distance divided by time, then time is going to be equal to distance divided by speed. So distance divided by speed, 56 divided by 70 gives us 3/4 of an hour. And I'm going to keep working in fractions here. So if I add that to 1 1/4, let's make it easier for myself. Let's go 5/4. So that is 41/20. And again, we could convert that into minutes, but I'm going to leave it like that for now. I'm going to work out my total distance, which is going to be 56 plus 61. So we're looking at a total distance of 117 and a total time of 41/20. So his average speed is going to be equal to the distance, 117, divided by that fraction, 41/20. And again, we can treat that like just like that. So if I go for my answer divided by, and I'm going to put in a fraction here, 41/20. That's not a very nice fraction. As a decimal, we've got 57.073 ... We're going to stick with that though. I'm going to go, that's 57.1 kilometers per hour. Right, Molly drove from Barnsley to York. Molly's average speed from Barnsley to York was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Molly says that the average speed from Barnsley to York can be found by working out the mean of 60 and 80 and 60. If Molly is correct, what does that tell you about the two parts of Molly's journey? So the most the most kind of straightforward way of viewing this is if we're working out the time for it to be the same, for it to be an average of 60 plus 80 divided by 2, it actually means that the time taken for both the journeys must be the same. Time taken for both journeys is the same, is equal. There is a slight caveat to that. You could have gone for a slightly different answer. Because if you think speed is equal to distance divided by time, if you kind of imagine whatever the distances were, if we kind of imagine it was, let's just say it was 80 in 1 hour and 60 in 1 hour, you can kind of see, obviously it's not going to be an hour, but you can see that if it was divided by 1 and divided by 1, if we would get the average of the two when we're trying to work out the speed. Because speed would be distance divided by time. So if they had equal times, we would just be able to take the average of the two speeds. The other slight one is if one of them is, well, if you imagine 60/80 is equal to 3/4, we could say if this one was 3/4 of the time compared to this one, but I wouldn't recommend going down that. But technically speaking, you could argue that Leeds to York is 3/4 of the distance between Barnsley or the other way around. But that was the most common answer. Right, question 30. The cumulative frequency graph shows information about the weight of 60 potatoes. Okay, use the graph to estimate the median weight. The median weight, we're going to go for the middle value. If we've got 60, the median is going to be at 30. So we go across and we read off our value by going down. So we're looking at sort of 56 there, I think. Yeah. Actually, so I mean slightly over. So I'm going to go 56 to 57. Obviously, you only give one answer, but I'm sure either one would be fine. Dobby says 80 minus 40 is equal to 40, so the range of weights is 40 grams. Is Dobby correct? You must give a reason for your answer. Um, I mean, technically, for a cumulative frequency graph, we for a cumulative graph, we don't know that the maximum value is 80, and we don't know that the minimum value is 40. So we don't know that max weight is 80 or min weight is 40. And less than 25% of the potatoes had a greater weight than 65 grams. So we've got two options here. We can either say if we can look at 65, and we can work out how many as a percentage have over 65. So we can go up to our graph and read off here. So if we're talking about we've got a total of, if there are 60, this value here would be 48. So we've got 12 out of 60. 12 out of 60 that are greater than 65. If we times that by 100, that'll give us the percentage. So 12 out of 65, not out of 65, sorry, out of 60. Times by 100, so that's going to be 20%. Show that less than 20%. So, show that less than 25%. So we have 20% with a greater weight. Than 65. Our other slight option would have said if we're looking at 25% and we've got 60, we could have looked at what the 45 mark was, and then we could have read that off and said that we've got more than 25%. Sorry, less than 25%. Either way, that is fine. Right, that brings us to the end of the paper. I'll bring up the question level analysis and sign off. Thank you very much for watching the video. I hope you found it useful. And again, if you did find it useful, please do subscribe if you like, and you'll get notified as soon as my other material is made available. Good luck with the rest of your revision, and I will see you soon.